question, people are doing it, and then but these are all included. So combining all, can we call it as a sustainable living? The output from our ecosystem, what we can say that output is, our target is, objective is to have a sustainable living. Okay, so that's what is the ecosystem. Now when we talk about ecosystem, with this freshwater ecosystem, the solar energy, temperature, wind, precipitation, well, all these are our input. And when we talk about ecosystem, you can see this is, we can subdivide it into some subgroup like groundwater ecosystem, stream ecosystem, lake and reservoir ecosystem, wetland ecosystem. These are the prominent subclasses. These are all independent ecosystem, but as we have already discussed, these are linked to each other. We cannot for studying, we suppose one is studying groundwater ecosystem, another person is, suppose another research group is studying stream ecosystem, another is studying this, but there is always the link between these things. So we'll have to work in group. And then of course we can talk about watershed ecosystem as well. So watershed is basically a system that is where suppose a outlet if we give, that I will be coming in my next talk, I will be coming in more detail, that where that it is considered as a single hydrological unit. When the raindrop falls, it will all moves to a particular outlet. So if we define the outlet, based on that, the area that contribute to that outlet, water that contribute water to that outlet, this is defined as the watershed. But then that can be very big or a small, even without having stream also there can be watershed. But then with a river also, if I consider Bay of Bengal as the outlet, then Brahmaputra river, Ganga river, all these things will be coming under this same watershed. So like this, considering our outlet point, we can define. So that way river basin, catchment, all these things can be looked into as a form of the watershed. Okay. Now let us come to some concerns of freshwater ecosystem. Well, we'll quickly go through this. That is stream ecosystem. Now what are the concerns? Why we need to go for green wizard? Like climate change impacted high intensity rainfall will cause increased sediment influx, resulting in mid-sandbar formation and increased bank erosion. Okay, like when our erosion is increasing, these sediments are coming more and more into the river, and then when it get deposited into the river, when the river slope get changed and comes to a flatter portion, then the sediment get deposited into the mid-sandbar in the middle of the river. Then the side channel get activated. Now when the side channel get activated, what happens? It will start eroding the bank. This is one process of erosion. There are several processes of erosion that we will be taking up in a different talk, but then that is one of our concern. Then another concern is that because it carries a lot of fertile soil, that is the existence of the fertile sandbar has attracted sandbar cultivation in braided river. In the braided river, we have sandbar cultivation, and this is causing changes in the riverine ecosystem. One thing is that now people are in the sandbar, on the side of the sandbar or point bar, which is connected to the bank also, but people are living there doing agriculture. So if erosion occur, serious loss is there. This is one aspect. Another is that when they are doing cultivation, if they use fertilizer, that may affect the water quality. So that way, both way, we should be very much careful. This is one issue. Then with deforestation and urbanization and climate change, spatio-temporal variability, that is particularly I will talk here about temporal variability. That is generally in India we have that monsoon water, but in other time of other part of the time we do not have that much of rainfall, so we have less water. So that because we get lot of water together in a very small span of time, we have flood and all this problem, and for other part we do not have the water to use for our need. So that's why this temporal variation, if we can reduce, that will help. But with removal of vegetation, with removal of with creation of surface pavement, now we have more and more flow is coming together, so peak is increasing, and that way this temporal variation is further decreasing, because groundwater is going down means the contribution to the stream in the lean period when there is no rain is becoming quite less. So those are becoming dry, and in the flood time all the water is flowing into the river quickly, causing flood. So that way, this temporal variation is of concern with our activities is happening. So we need to apply all those green measures that we have mentioned so that we can reduce the temporal variation and can use the water for our benefit. So that's what is one concern. And then for power production, increasing demand of energy is also, or increasing demand for irrigation, domestic and industrial water, for all these are inspiring augmentation. That means we are having now reservoir to have more water stored and in a very artificial way. But then these are sometimes needed, but then if we can store it more naturally, then need of artificial storage will also go down. Of course, for power production, we need to store some water, and then this need to be done. These are need to be done with utmost care. Okay, this is what is one concern. Excessive river mining, this is another concern. When we are taking boulder and sediment from the river bed are getting exposed and water, so muddy water is going to the downstream. River level is going down because it is becoming deeper, so level is going down. And this is infecting, this is again have another impact on the agricultural land. What is happening when the river water is going down? The soil water from the neighboring or nearby paddy field or agricultural field is also coming out. So water is flowing to the river quickly. So it is not getting stored as the level is going down. So this is becoming another concern. Our agriculture is suffering. So this is what is again another concern, that is the ecosystem is getting disturbed. So all this can affect the aquatic organism, movement of nutrient bearing sediment, and can reduce the aquatic biodiversity, which is another concern. Okay, this is what is the phrase. So I am just giving you some photograph that how cultivation is going on in the river sandbar. This is one study how the vegetation is increasing in the sandbar, and the sandbar without vegetation is going down. So this kind of study is showing that what is going on in the riverine ecosystem to fulfill the need. So that we need to do more carefully. We need to do it, but we need to do knowing the facts and then taking utmost care so that the change become beneficial for all the living being, including human being. Okay, so that is what is one concern. Then we will talk about groundwater ecosystem. Now when we see the groundwater ecosystem, drawing of excessive groundwater in winter lower the groundwater table, and we are having more fluoride bearing groundwater in many places. Arsenic is coming up. So when we are drawing water, our water table is going down. We require more power for pumping it out. This is one concern. And then also the quality is getting changed. That means when it is going to a deeper layer, there may be different minerals, different rocks that is releasing some of the pollutant that is not beneficial for us. So this is one concern. Then again, to replenish the groundwater, we are to replenish the groundwater, and also to reduce water logging in the and flooding. Groundwater research is being carried out. So utmost care needs to be taken so that we do not recharge the groundwater with polluted water. We need to do recharge, but if we put polluted water, that can have different impact, because many people think that in groundwater there is no life, but then it is not like that. So many microbes are there in the groundwater, also in the groundwater aquifer. So many things are happening, and then viruses are also there. So when we put some polluted water, how the different things carried by the water, how it will be reacting with those things, that is again a major concern. Even for example, I am giving you that aquifer contains microbes and different viruses, different nature at different levels, and then a virus like poliovirus. Okay, poliovirus can remain active for 460 days in sandy soil. So it is almost more than 1 year. And then, so if it remains active and if we pump water from there, there is another concern. So this is how the groundwater ecosystem, these are the concerns that we need to take. So I am giving you one example how we are designing that pond, that is the sustainable approach of rainwater management and application. So we call it as a Sarma system, not Arup Sarma, but it is the SARMA, sustainable approach of rainwater management and application. Our research group has developed this one. By this, what we are doing, that we are taking the water which is through a channel, but and it is coming over a grassland, and so it is clear water, and then we put a filter there. That filtered water goes into it, and then up to this much it is a utility storage. This part of water we can utilize, and then when it crosses beyond that, it is a flood cushioning. Extra water coming, it is going there and it is infiltrating. We put it down to the groundwater there through a well, and then when for our use, so this is flood is getting reduced here. It is a flood cushioning storage. Also, we can utilize this water. Now, when we draw water, first initially it will draw from there, and that's why your power requirement is less. Then, of course, if it get exhausted, then it will be drawing from there also, from the groundwater. And then we are, we are doing the agriculture or irrigation here. That water is again coming down. If it is urban, then we will go for day-to-day use. If it is agriculture, we go for irrigation, and then it is again coming back to this pond. There is a lining of, it can be impermeable lining, and that way we are designing this one. And then actual size of this requirement, it depends on what kind of purpose we are doing. And this was done, that this system has a multi-purpose benefit, like that water utilization for household application, irrigation in water stress situation, because that water can be used for irrigation, flood moderation, as I have explained, groundwater research, and that your waterlogging problem can be solved, pisciculture, reducing waterlogging. These are combined effect. And then carbon sequestration, the sediment of that pond has a good potential of carbon sequestration and reduction in power consumption, because we are drawing water from that slightly shallow, so we are having power consumption less, so it helps in carbon emission, reducing carbon emission also. Then microclimate moderation, this is one important point, that we are talking about the temperature increase by 1%, 2% kind of thing, 1 degree to 2 degree kind of things. Now with this kind of pond, if we apply that in a garden, this was applied, and now there is a 9 such pond, I am just showing few. So with that, we observe that microclimate, how it is changing. These are the pond where we have the temperature of around 29.94. Here it is 31.9. 2 degree difference we could see. We cannot change the climate very readily, but then with this microclimate moderation, we can have the benefit of favorable temperature. Okay, we monitored it for 1 year continuously, and all the season we are finding this. And this was a tea garden, for it was beneficial for their tea plant also. And interestingly, we designed this one because they had waterlogging problem, and in waterlog situation, the roots spread like this, it cannot go deep, and that way the plant gradually dries. So to solve that problem also, we apply this one, and then you can see that is where the waterlogging problem is there. And then when this method was applied, and after application of this method, I am not going into detail, you can see that when waterlogging situation was there in near this, that crop were not growing, but after implementation, the crop were growing so green, so good, quality is improving, price of tea is increasing. So the party who implemented this, the garden who implemented this, they are gaining benefit. The cost put into the work is already coming back as a income. So this is what is. Similarly, we are talking about lake reservoir ecosystem. Okay, so like in the Himalayan reach, we have so many lakes: Nainital, Bhimtal, Sattal, Naukusia in Uttarakhand, and Dal Lake in Kashmir. So Loktok Lake in Manipur. So many natural lakes are there. Okay, so many tributaries and small streams carry sediment and other pollutant to these lakes. So now point is that when these are carrying, because of urbanization, it is carrying polluted water, sediment is going. If we apply the watershed management measures, all those methods we have discussed to stop those pollutant and sediment, then this lake can be maintained properly. Similarly, we have some reservoirs, man-made reservoirs, and there are some concern for power generation or for various other water utility, water resources projects are there. Now there are concern that with those things, our sediment regime at downstream is getting changed. So reservoir is there, now sediment get deposited in the reservoir, and that's why at a downstream, when we are moving, the sediment volume is reducing. And then again, if it is a power project, the flow at the downstream get changes, that we call as a diurnal variation. So those kind of things are happening, and these are changing the ecosystem. But again, those changes knowingly when we are doing, we should be doing in a way. There are technology which can reduce these changes. I'll just bring quickly to that point. But there is another point at Borapani Reservoir in Meghalaya. I'm just giving an example. There are one river Umiam where the storage is being made, and that water is diverted, and at the downstream in another river, that is, it is basically a basin transfer kind of things. 4 other downstream hydro projects is there where power is produced. It was constructed in 1960-64, so almost 5-6 years has gone. And then this Umiam river, though it was diverted for power generation, and our hydrological study, how much hydrological alteration is there, that we also studied, and there is a significant alteration. But then now it has reached a balanced situation, because downstream, they have done downstream of the main river where the water, from where the water is diverted, and the downstream they have gone for rainwater harvesting and cultivation in a very systematic scientific way. So these are also going on, and that all things has reached a new balanced position, and people do not know that this Borapani reservoir is an artificially made reservoir. People think that it is a natural lake, and all goes for the recreational. There is a lot of tourism happening all around the lake, and that way it is providing the ecosystem services in the form of tourism. So like that, if we do it properly, we can have the benefit. So we will have to be very much careful, or carefully it should be done. Like that, this is one example I am just giving, that in one reservoir, when it was constructed, before that at the downstream sediment were in this level, but after construction sediment has come down to this level. Okay. Similarly, because of hydropower production, suppose this blue line is showing that what is the naturally coming and how it is happening. This pink line is showing that during power production, how high water is released, so the flow become very high, and for other part of the time, day, the flow is less. But then with a small regulating pond created at the downstream, that we call as a regulating pond. So with that, we can bring the, without compromising with the power, the flow can in the river can be kept near to the natural flow. So like that, these are some of the system or some of the technology that are being developed for maintaining the ecological balance. Okay, so like that, we can keep on going. Some other method also we can take up, like that if we regulate the demand side for the power, like that we have a large country, if we make the time zoning different, or if we allow some incentive for producing power in the lean period, that means in the daytime or late night, then the power demand also get flattened. When power demand get flattened, then this diurnal variation also get reduced. Of course, detail of that I am not going now. So with that, similarly, wetland ecosystem is another very important ecosystem that we are very much concerned. So in India, we have lots of water bodies having shallow depth, which we refer as wetland. Okay. Now, concern is that most of these wetlands are saline water wetland, and this northeastern part of India in Assam, we have lot of freshwater ecosystem. Bengal, we have some freshwater ecosystem on the upper side. So in Uttarakhand, I am not very much sure what is the situation there. So these wetlands provide ecosystem services, lot of ecosystem services to the human being for beneficial, in a beneficial way. But as many of these wetlands are getting shrinking due to encroachment. Some changes are also happening, as many of these wetlands, due to construction of the flood embankment. So river and wetland has some connection. Many wetland has some connection with the river. Now when we block the river by making embankment, this connection is getting lost. So these are changing. Now, so we know that there will be some change. So how these do not become detrimental to the ecosystem, how we can do it in a, can we have gated embankment? So these are some of the concerns that we need to look into. Similarly, urbanization and farming of fertilizer, farming with fertilizer have led to pollution of this kind of wetland. So the wetland has the capacity to remove this nutrient pollution, as I have already explained beforehand. Based on that, therefore, people are also constructed wetland, and so this is how the wetland we need to save wetland. At the same time, we need to learn also from the wetland. Okay, so like these are different sub ecosystem that we have discussed, and the method what we have told already that we need to look into. So impact of urbanization, as already we have discussed, that is the green building part we need to talk about. Okay, so this green building, this is an important component of the ecologically sustainable urban development. Okay, urbanization cannot be avoided. However, the way of urbanization can be changed like that, with a focus towards reduction of climate change and anthropogenic impact on our dwelling places. We must think about eco-friendly development. Okay, now concept of green building need to be popularized more and more. So what we mean by that, a green building is that, I mean, this definition can keep on changing with time, because when we see that a lot of different innovations are coming, the definition also need to upgrade. So like that, green building is that which does not disturb the ecological balance. This is the first point. The second is that energy efficient because of its orientation. We need to orient it in a way that without AC we can run it to the extent possible, or that if it is very cool, then we can have warm orientation like that. Construction material can be changed so that it remain in a favorable condition. Rainwater harvesting can be done there so that we can utilize the we can reduce the utilization of pumping energy for getting the water from the ground. So that way we can make it energy efficient. Solar energy we can use for most of our work there in that building. And we do not disturb the natural water regime and do not produce polluted water. Whatever wastewater comes from that, or the sediment that comes from that, if we allow it to pass through some phytoremediation system with plant and vegetation, and if we allow it to pass through some sediment layer, horizontal layer, or depending on the scope we can put vertical layer, all those, and then if it goes to the outlet, it will be going with a clear water. So that kind of building we can refer as the green building, and that we need to promote. Okay, with this, what I am finally trying to conclude, as I said, that in urbanization, urban we cannot afford, but now it is happening as if urban means unfortunate reality built against nature. And that kind of things we are having, all flood everywhere. In all urban area of India, we are having flood. But urban can also be thought as URBAN, unique, rationally built, admirable nature. This is the campus of IIT Guwahati. Here also we have done urbanization, but in a way that it is not disturbing our system, rather it is improving the system. So that way we need to live. Then rainwater as much as possible, naturally we should conserve, and then people, our children, we must train with this kind of rhymes that raindrops, raindrops, fill our glass. Don't go to ocean, stay with us. So like that we need to train to live happily, LIVE, to live happily, live with nature, to live early, LEAVE, to live early. If you want to live early, live the nature. So that's the very philosophy we feel. Then we need to go for green structure or green infrastructure so that we can have a better life. Okay, thank you very much. Thank you all. And in the talk, several contributions of several researchers, those has worked with me, those have worked with me, some project staff, and then several funding agencies. We had links, so we get contribution from different funding agencies to carry out various research. So it all, thank you very much. I hope that this will be beneficial for you. And if you have any feedback on this, because this is not a one-way thing, now it is one way. So if you have any feedback, please give the feedback so that it is a system, online system kind of things. If I get your feedback, I'll be able to improve my thinking. And then by sharing our thought, we can have a better world for our future. Thank you very much. Thank you all.